In this video, I'm going to discuss the answers and the explanations for the Unit 2 test review. For number 1, they give you that VQ is perpendicular to RB. Key word here is perpendicular. We know that the definition of perpendicular says that two lines form a right angle. So the conclusion we're going to make in this picture is that angle RVQ is a right angle. The reason is definition of perpendicular lines. In number 2, it says that angle ACE is complementary to angle BCE. ACE, BCE. Keyword is complementary. There are a couple of conclusions we can make here. Conclusion number 1, we can say that the measure of angle ACE plus the measure of angle BCE is equal to 90 degrees. We could also, since these two angles are adjacent to each other, we could also say that angle ACB is a right angle. And our reason for both of those statements would be definition of complementary angles. In number 3, they give us that TP is congruent to SP. They give us that PY is congruent to XP. You can see here these segments are adjacent to each other. So this is a situation where we're going to do some additions. We're going to say that TY is congruent to SX. Reason, this is the segment addition postulate. In number 4, they give us that E is the midpoint of DF. Midpoint is our key word here, so the midpoint splits DF in half, so that means that DE has to be congruent to EF. And our reason, definition of a midpoint. Okay, in number 5, they say that TY bisects SR. Key word here is bisects. It's a segment bisector. We're splitting SR into two equal parts. So TY bisects, that means SY is going to be congruent to YR. And this is definition of a segment bisector. Okay, for number 6, they're telling us that angle 1 is congruent to angle 4, and angle 2 is congruent to angle 3. So you can see here, again, we've got angles that are adjacent to each other. There's no overlap. So this is going to be a situation where we're adding together the angles. So it's going to be angle ADB is congruent to angle BDC. And the reason on this one is the angle addition postulate. Okay, for number 7, we're given that DE is congruent to FB. You'll notice between these two segments we have a gap. When there's a gap, we're going to use the reflexive property. So we're going to say EF is congruent to EF. That is the gap. That's reflexive. There's a gap. We're also going to add that. So EF is going to be added to DE. So I get my other conclusion is that DF is congruent to EB. And that's going to be segment addition postulate. Okay, in number 8, they're telling us that X is the midpoint of TR. So that means TX is congruent to XR. They're also telling us that Y is the midpoint of SR, so that means SY is congruent to YR. They're also telling us that the whole line TR is congruent to SR. When we have three statements, that's an indicator to us that we're going to have the halves postulate. Now, the statements or conclusions, we have four possibilities. I can say that TX is congruent to SY. I can say that TX is congruent to YR. I can also say that XR is congruent to SY, or XR is congruent to YR. Again, you only have to make one of those four statements. Indicator, again, with halves postulate, it has to be one part from this line and one part from the other line. Okay, for number 9, this is one where we do not even really need to see the picture. You'll notice that we have angle 1 is congruent to angle R, and angle R is congruent to angle 2. So the R's are diagonal. This is an indicator that we're going to use the transitive property. We're going to say that angle 1 is congruent to angle 2, and the reason is transitive. Okay, and number 10, they tell us SX bisects RST. So here is SX, here's RST. So basically, keyword here is bisector. Conclusion, we're going to say that this angle is congruent to this angle. So angle RSX is congruent to angle XST. And that's going to be definition of an angle bisector. Okay, for number 11, that'll give us that angle DAB is a right angle, so DAB. So that means that we can put a little box down here in the left corner. I know it doesn't really look like a right angle, but because they give us that, we can state that. Now, a couple things we could say. We can say here that angle DAB, the measure of that is 90 degrees, and that would be definition of a right angle. We also have another definition we could use. We could say that line segment AB is perpendicular to DA, and that would be definition of perpendicular lines. We could also say that angle DAC, that's this angle, is complementary to angle CAB. And that would be definition of complementary angles. Okay, for number 12, they tell us that AF is congruent to EG. So again, here is AF and here is EG. So hopefully you notice here we've got some overlap. When we have overlap, we're going to use the reflexive property. So the overlap is EF. So conclusion 1 is that EF is congruent to EF, and that reason is reflexive. Remember, when we have overlap, that means that we're going to subtract. So if I subtract EF from AF, I get AE is congruent to, and I'm going to subtract EF from EG. That's going to leave me left with FG, and that's going to be the segment subtraction postulate. Okay, and number 13, they're giving us that TSR is congruent to RTS. So this angle and this angle are congruent. And then XSR, which is this angle, is congruent to YTS. That's this angle. Again, notice here that in our picture we do have overlap. So if we get rid of the overlap, we're going to be left with angle XST is congruent to angle YTR. And this reason is simply angle subtraction postulate. Okay, for number 14, they're telling us that angle 1 is congruent to angle 3. This is a situation where we have a gap. So conclusion number 1, we're going to say that angle 2 is congruent to angle 2, and that's going to be reflexive. Again, when there's a gap, we're going to add. So this is angle ADB is congruent to angle JDH. And this is going to be the angle addition postulate. Okay, in number 15, we've got a couple of possibilities for our conclusion. They're telling us that EF is congruent to FB. These are two segments next to each other that are congruent. So one possibility is I could say F is the midpoint of EB, and that would be definition of a midpoint. I could also say that CF bisects EB, and that would be definition of a segment bisector. So both possibilities, you would only have to make one of those statements and only have one of those reasons for number 15. Okay, number 16, this is one we do not need the picture. Hopefully you notice the 6s are stacked there. So this is a situation where we're going to say that angle 5 is congruent to angle 4, and this is just simply substitution. Remember, when they're stacked, it's substitution. When the two angles are the same and diagonal, that's transitive. Okay, for 17, they're telling us that the measure of angle S, that's this bottom angle, and TPX equal 180 degrees. Well, because S and TPX are not adjacent, we can't say that it's a straight angle. But what we can say is we can say that angle S is supplementary to angle TPX. And this is just simply the definition of supplementary angles. Okay, for number 18, they want us to determine if the statement is true or false. Now, for the statement to be true, there cannot be any counterexamples. So in this particular one, if two angles are supplementary, then one is acute and the other is obtuse. Well, this is technically a true statement. However, there is a counterexample to this. It's possible that the angles could both be right angles. So we're going to say if two angles are supplementary, then together they add up to 180. So the sum is 180 degrees. So we would have to say this is false because it's not true 100% of the time. Okay, number 19 says complementary angles are never congruent. Again, for this to be true, it has to be true 100% of the time. It's not true 100% of the time because complementary angles could be both 45 degrees and 45 degrees. So again, this would be a false statement, with my counterexample being two 45-degree angles. Number 20, it takes 2 points to determine a line. This is a true statement. We only need 2 points to make a line. 21, if two planes intersect, then their intersection is a line. That also is a true statement. Okay, for number 22, it wants us to make a conjecture about the next term in the sequence. So as we look at this, we see here that we decrease by 15, then we increase by 30, and then we decrease by 60. So on the next one, we are going to increase by 120, which when we increase by 120 will make our next term 80. Okay, for 23, it says make a conjecture about the next object in the sequence. So notice we've got a shaded triangle, a non-shaded triangle, both with 3 sides. Then we've got a shaded square and an unshaded square. Those both have 4 sides. Then we have a shaded pentagon and an unshaded pentagon. So the next figure is going to be a hexagon, which has 6 sides, and it's going to be a shaded pentagon, or I'm sorry, a shaded hexagon. And then the next one, and if we had to pick the next one, would be an unshaded hexagon. Okay, in number 24, they want us to write the inverse of the statement. So the inverse of the statement, remember, is going to be the negation of the first, then the negation of the second. So I could say if x does not equal 2, then x plus 3 does not equal 5. And that would be the inverse. Okay, for 25, they want us to write the contrapositive. Remember, the contrapositive, we're going to take the negation of the then, and then the negation of the if. So it would be if x plus 3 does not equal 5, then x does not equal 2. That would be the contrapositive. Okay, for 26, it says if the absolute value of n is a positive number, then n is a negative number. They want to know a counterexample. Well, a counterexample would be any number that we put in for n that is positive. So the best choice for 26 would be letter J. 10 would be the counterexample. Okay, for number 27, it says if x plus 4 equals 5, then x equals 1. And they want to know what is the hypothesis. The hypothesis would just simply be x plus 4 equals 5. It's the if part of the statement. For 28, it says if cats fly, then ducks bark. They want to know the converse. That would be if ducks bark, then cats fly. Okay, for 29, they want us to write the inverse statement of if a triangle has 3 equal sides, then it is equilateral. So we would say if a triangle does not have 3 equal sides, then it is not equilateral. And that would be the inverse.